Hi, in this video I'm going to update my progress with my Kickstarter project. This is the webpage on Kickstarter for my project that was successfully funded on April 6th. It's for developing a open source building toy that supports doing curves, curve shapes. So there's a picture of the building toy, and there's a picture of me, just in case you're wondering what I look like. So this is that model in SketchUp, and we can rotate around it and see some of the connection possibilities. And so I now have the 3D printer. I have the other tools that I need to actually start prototyping. And here's the SketchUp model of the one half of a hub. The two halves are identical. That I'm using to do the hub prototypes. And it took me a few iterations to get to this, but this is actually working pretty well now. And as you can see, it's only it's like 1.5 inches across the long diameter of the hexagon. And this way, it's like 1 1/3. So let me show you now what the prototypes look like. So here are some prototype hubs. This is the first one. Pretty close, as you can see. The ball stays nicely in the joint, but needed to make it's a 1/2 inch ball, and I made these ball joints exactly 1/2 inch. This was just a little too tight. So this is a second iteration where I just made these a little bit bigger, but I needed to make the center hole bigger still. And this is the best iteration so far, what I'm using as I go forward. And I may there's lots of modifications that could happen with this, and maybe some people will start playing around with this and trying different things. So now let me show you these in action. So here is a triangle made with the hubs. And as you can see, they have really nice flexibility, which is what I was hoping we would get. And the balls stay nicely in the joints. I'm just using some threaded rod and some steel nuts here. At any rate, this is nice. Here's why having physical parts of the prototype is so useful. I think. I say I think because I don't know whether this experiment is actually going to work. But so as I was playing with the flexibility of this last night, and other people who've played with it also like to sort of twist it and experiment with that flexibility. I thought, and I've thought of this before, but how could you possibly make it so that the joining pieces also could change and be flexible? And it occurred to me, these are hollow tubes, and it occurred to me if I had a rod that fit inside the tubes fairly snugly with some friction, then I could cut the tubes, insert the rod, and then I would have, then I would be able to do that. And I checked out in my workshop, and I just happened to have some aluminum rod that is exactly the right size. And so what I'm going to do now is go cut these connectors and insert the rods, and then show you how that works. Okay, be right back. So I'm back. This is the rod that I inserted. It's 1/8 round aluminum. And you can see it here inserted into the acrylic plastic tube. And it certainly does give you the ability to change the shape of the triangle. So not only do you have now flexibility in terms of angle, you also have flexibility in terms of length. So that's pretty cool. It definitely makes it much more viable to work with these shapes, to build with these shapes, to make a flexible, adjustable shape. So that's where I am right now. I want to, moving forward, I'm going to be making more hubs, making larger structures, experimenting with different materials for the tube. It's possible that you could use wood here. You can get 1/8 wood dowels, which would be kind of nice. So love to have other people playing around with this and seeing what they come up with. Anyway, that's it for now. Thanks.